Gill Pratt, you flew in for this,
Yes,
but this is your old home.
it is indeed, yes.
How many years did you spend at MIT?
So I was here for 21 years.
And then you went to DARPA.
Well, actually to Olin College first. Same place that Dave Barrett's from.
He's a great guy.
Absolutely.
Listened to his panel earlier.
Yep, and then DARPA after that.
And now you're the CEO of Toyota Research Institute.
Yes, that's correct.
Quite a disappointment to your family. Wow. Okay, so
great.
I think it's best to start out by defining the Toyota Research Institute. What do you guys do, and where do you sit in Toyota's organization?
Well, the idea is to use artificial intelligence for improving the quality of life. And that's the general big goal. Now, of course, Toyota is the best known for making cars. So we're using AI to make cars safer, to make cars more accessible, and also to make them more convenient. But beyond cars, we're also looking at aging society, people growing older. And that's true in many different parts of the world. And we think that robots can be used, in fact, to improve quality of life for people within their homes, not only within their cars. So that's the second thing that we're doing. And then finally, we have a small effort on using artificial intelligence for helping material scientists to discover and design new materials.
Great. So we'll touch on autonomous cars and AI at the end. But why is Toyota spending so much time and resources on assisting the elderly?
Well, there's a lot of them, and there's going to be more of them, and they're going to be us. And it's a very serious issue because in the US, for example, right now 13% of our society is over age 65. You've probably heard of the baby boom. Well,
I've heard of it.
In 15 years, that number will grow from 13% to 20%. And that's proportionately a tremendous increase. And a reasonable question is, who's going to take care of us? And it's not the case that older people are being taken care of very well now. And we think that robots can make a tremendous difference. And if you think it's bad in the US, in Japan it's already 20%, and it's growing there to 40%. So imagine a society with 40% of the population over age 65. The same thing is happening in other parts of the world. It'll affect China as well, perhaps even worse. So we really do need technology and robots and robotics in particular to make life better.
Maybe the baby boomers should have raised their kids better. So give me some examples of the tasks that these robots are designed to address, and what forms will they take?
So a lot of them are things that you might think of, helping to keep the house clean, helping to organize things. But there's a whole lot of subtle things that you might not think of. Not only physical tasks, but emotional tasks as well. Start out with a robot that remembers where everything is within your house. As we grow older, for many of us, we begin to lose track of things. Even when you're younger, where did I leave my keys? Things like that. But the robot doesn't necessarily only have to be within the house. So the robot is for the aging person within a particular place, but maybe robots are outside helping the person feel a little bit less physically constrained. They may be physically stuck in their house most of the time, but that doesn't mean that virtually they can't be other places as well. Think about something better than watching television, where you're just this passive receptacle of wherever the camera happens to want to go. What if it worked a little bit in a more bidirectional fashion? There's lots of different ideas that we're thinking of.
So would these be humanoid-type robots, or are they different forms?
We're not sure yet. We try to be as unbiased as possible. You may know in the DARPA Robotics Challenge that I ran at DARPA, a lot of the robots were humanoid, but some of them were not. There's a lot of attraction to that shape. It's kind of cool from a science fiction point of view, and some practical advantages as well. But what we really believe is you have to look at the task to be done, look at the business case for it, figuring out what's the most practical way to do it, what's the most economical way to do it. And to some extent, the emotive part, whether having a humanoid form or some other form that people can bond with, we think that's very important also.
Yeah, my wife is an in-home hospice nurse, and part of what she does is emotional support.
Yes.
How can robots provide emotional support?
Well, first of all, I'm not an expert on that. There's been some tremendous work here that was done with, starting with Kismet at MIT, and certainly at other places as well, I think people have this incredible ability to empathize with machines as well as with other human beings. And it's sometimes kind of a little spooky, so we have to make sure that it actually works for the good and doesn't get too weird. But I learned at the DARPA challenge, actually, that it's incredibly strong. So for example, we had the MIT robot at the challenge fell over and it broke its arm. And a reporter at the news conference at the very end of that day remarked with sort of tears in her eyes, it was like, is the MIT robot gonna be okay?
Yeah, totally.
And I sort of looked at her and of course I've been steeped in this thing for a long time, and I said, I think it'll be okay.
Well, you say that, but we had Big Dog at Disrupt, which is our big 3-day event, much like this, last year. And it did the same thing. It essentially had a seizure, and I was this close to it, and it fell over.
Yes.
And I really did feel something.
Yes.
And I'm pretty cold inside, and I felt that. And so there is this thing that I can feel emotion for that, but will it feel emotion to me?
I think that the theory of mind, as they call it, the modeling of what's going on in each other's heads has to work both ways. And we do still have some ways to go. I don't personally know how complicated emotions are. I don't know how complicated yours are. But
not complicated at all.
But I feel that may not be as hard as we might worry. That in fact, we can build machines that will be able to track, or we will someday be able to build machines that will track how we feel.
Do you see cultural differences between the US and Japan?
We have noticed some. I'll give one example. In the US, it's considered nirvana to have a robot that will work at home and keep our house clean. The Roomba is a great example of that. But even to go beyond that, to straighten up after dinner, to really act as if we had a maid all of the time. In Japan, as people grow old, it's often the case that the person who keeps up the house will feel tremendous pride that they can still do it. And so it's actually something that you don't want to have a robot take away from the person, because that's part of their sense of meaning, their sense of purpose. So we're trying to be culturally sensitive and trying to look at what different people around the world might want the robot for.
Great. So at Toyota, to wrap this up, at the Toyota Research Institute, is this just research for research's sake, or is there a path to commercialization?
It's absolutely not just research for research's sake. We have very much a set of projects and a pipeline from research to development to more advanced development, and then marketing that we're thinking of for all these things. The autonomous cars we think of as coming first. Robots within the home we think of as being next. And then the work that we're doing in material science is more far term.
Okay, great. So talk to me about TRI's M&A strategy. Last week or 2 weeks ago, you invested $14 million in a Bay Area robotics company. If you were a student or a startup, how would you market yourself to TRI?
Okay. So first, just to clarify a little bit, we led a $14 million round in that company, and it's up to the companies themselves to decide whether and what to announce with regard to who spent how much. So that's just a slight tweak on what you said.
No worries.
The most important thing is to indicate to us what you want to achieve. And we're going to run this thing kind of in two ways. Like a traditional venture capitalist, we're going to listen to pitches that come in and try to decide, is your idea a good one or a bad one? And actually try to waste as little time as possible if maybe the answer is no, because we think that you deserve to have that figured out as efficiently as possible. But in addition, I learned a whole bunch of stuff when I was at DARPA, and we're going to try to do some of that too. And we call that call and response. We're going to publish on our website a set of calls for problems that we have difficulty figuring out by ourselves. And we're looking for startups that might want to address those problems. So my recommendation would be to look at that website. We'll have a means of signing up for those things, and see if you genuinely have some clever way of solving the sort of problems that we need to have solved. The advantage of working with us or any other company that sets up a fund like this is that you know from the outset that you have a customer for the product that you're thinking of doing or for the idea that you're thinking of solving. Often in the other case, when you just go to a VC and you pitch them, even if they give you money, neither one of you actually knows if somebody wants what you have invented. And so I hope that some of that will help to attract some talent.
Great. So I have two more things before we get to audience questions. And I talked to Ty Brady about this earlier today. Over the weekend, Elon Musk again called for the US government to regulate AI, calling it the greatest threat to our civilization and could cause social destabilization and job loss. So do you agree, should AI be regulated?
So I would agree that there may be trouble with some of these things. I think that the job loss concern is quite real. And it's not that we haven't had job loss because of technological developments before. This has happened quite a bunch over our history, but the rate of change seems very high now. And I think that as a society, we need to work very hard to make sure that we adapt as quickly as the technological changes are that are displacing labor from one field to the other. After all, most of us used to farm, but that's not true anymore, but we had many decades to get used to that change. So that may happen more quickly than it has before, and we need to figure that out. Social disruption, I think, is a little bit, I'm a little more skeptical on that. And I think that it depends on us establishing checks and balances to make sure that whatever the technology it is that we use to determine what is going on in the world, in other words, the decisions that get made, whether they're by an AI system or by just a group of people who are in power, we always need checks and balances on those. And I think that we can figure out how to do that with AI systems as well. So I'm very much an optimist on these things.
Great. So should the government regulate it or not?
I don't know. I think that it's easy to see it getting out of hand, and some of the emotional reaction to science fiction dystopian descriptions of our AI overlords, for lack of a better word, getting in the way, because that's not really what's going on. The deep learning systems that we have, which is sort of what spurred all this stuff, are remarkable in how well they do given the particular tasks that we give them. But they're actually quite narrow and brittle in their scope. And so I think it's important to keep in context exactly how good these systems are and actually how bad they are too, and how long we have to go until these systems actually pose that kind of a threat. Now, a danger does exist in the misuse of these systems beyond the capabilities that they have. But for instance, having discrimination pop out as a side effect of an AI system that is purportedly measuring some other dimension of statistics would be a very bad thing. But those kinds of errors can be made even without deep learning. And what it takes is checks and balances and review. And I don't know whether and to how much extent government legislation is necessary for this, or whether our press and other social bodies can do this work. But I think the answer is a lot of the same traditional things that have kept misuse of statistics from occurring within the past.
Great. Well, that's a fair answer. So last thing before we get to the questions, your career path is very interesting to me. You went from MIT to DARPA to Toyota. Said another way, you went from academia to the US government to Toyota. What did Toyota say to you to get you to come work for them?
Oh, what a feeling.
Yeah.
So it's a great question. I had admired Toyota cars ever since I was young because I love both electrical engineering and mechanical engineering and computer science, which if you think about the robotics field is like, the perfect three things to love. And just by chance, because I was a grad student here at MIT with many other friends, I used to fix all their cars. And Toyota cars were always the easiest to fix and always broke down the least. So I was sort of biased in favor of the company. But what really cinched it is that I was brought in for the interview, and the person who was interviewing me was Japanese, and I had a translator there. And the first word that they wrote down on the piece of paper and held up in front of me was dementia. So you're at an interview with Toyota, and they hold up a sign that says dementia. And I'm not sure whether they were referring to me or, or what was going on. But quickly it became apparent that what they're worried about is the future. And it's not only that older people don't drive cars or older people don't buy cars, it's that in Japan in particular, there's this demographic crisis that's coming, and it's happening in other parts of the world too. And if we could figure out a way to make people who are growing older have their quality of life improve as much as the car has improved our ability to get places, boy, wouldn't that be an incredible thing? And so that's how the conversation started. The real clincher was when I went to Japan and I met with the president, Mr. Akio Toyoda, and the conversation, which lasted an hour, was mostly about love. And again, here I am in the belly of this Japanese car company, which is all about efficiency and Kaizen, which means continuous improvement and stamping out cars. And I'm talking to the president about love. And he talked to me about the difference between a refrigerator and a car. He says, many people love their car. Very few people love their refrigerator. So I thought about that. I said, yeah, it's true. It says, so when you make an autonomous car, how can you make it that people still love the car and that it doesn't become like the refrigerator? And that was a remarkably deep question, very thoughtful question about AI and autonomy and about this special bond between people and machines, which is, in some cases, can be a very beautiful thing. And that's part of the challenge and what I thought was so exciting about TRI.
I think a lot of the people that were up here and in the audience were exposed to advanced engineering and robotics at a young age. How did you get into this?
So I was really fortunate. I had wonderful teachers in school, and then particularly when I was in high school, I started working first just sort of going to Bell Laboratories in Murray Hill, New Jersey. I was an Explorer Scout. It was actually run out of the Boy Scouts. And this was a once-a-week program. We spent 3 hours each week there, and it completely opened my eyes to what was possible. I don't know how many of you are old enough to remember Bell Labs, but it was an extraordinary place. And you would walk down the halls there, and each door, which had a glass window, would show off just an incredible lab. And it just gave me a glimpse of what was possible for the future. And the place ran incredibly well, and of course was this powerhouse of invention. And I went from there to working at MIT, first as a student and later on in other roles, and it was very much the same thing. So from my perspective, the key thing to do to inspire young people is to expose them to what's possible. And once they know what's possible, I think many of them will choose to go there.
I'm a Cub Scout leader, and I just bring them to my house, and we play Legos.
So
Bell Labs sounds fantastic.
That'll work too as a start.
Oh, well, good. Fair enough. Well, I think we have a couple questions. We have a couple minutes. Jordan, is she back there?
Here. Okay, let's do this. Let me just pull out my trusty computer. Okay, how do traditional auto manufacturers survive in the age of Google, Apple, and Tesla? And follow-up, does Silicon Valley need Detroit as much as Detroit needs Silicon Valley?
Yes. I think it's a really interesting question, and it's kind of gone back and forth. The automakers, and I think Toyota is, I will boast just a little bit, the premier example of this. They really know how to build cars. It's incredible the skill and the intelligence that's gone on in that field. It may be that writing software is actually not the key technology that is necessary, not the key skill. Because in the end, the software that's needed for deep learning and AI these days is mostly open source and widely shared. And what seems to matter the most is the training data that is used in order to train these systems in order to perform well. And the level of performance that we need to make these cars as safe as they need to be is extremely high because human driving is incredibly good. We're actually quite safe when we drive. 1 fatality per 100 million miles in the US for human driving. And that includes drunk driving, distracted driving, all of that stuff. So how can we make these systems much better? And the answer may not be the particular lines of code that are written, but actually the volume of the data that's necessary to collect in order to train these cars to be better. So it may in fact be that the advantage of car companies in collecting a lot of that data may give them a boost too.
I think Toyota will like that answer. Let's do one more.
Okay. If autonomous cars prioritize safety over all else, how do you account for human drivers bullying them on the roads?
It's really difficult. And I think that in the same way that it's difficult to respond to a human driver that bullies any of us, the autonomous car is going to have the same problem, except it's going to have a handicap, which is that it's expected not to respond in kind. And so Professor John Leonard here from MIT, who works part-time for us, he speaks a lot about the unprotected left-hand turn, which is a great example, where you have a long string of cars on a crossroad and you're trying to make a left-hand turn. And how do you negotiate letting one of them let you in? Because with human drivers, of course, you know, some of them, and they tend to be in certain types of cars, we all know, tend not to let you in, and whereas the other ones in sort of lower class cars are very nice, I won't say, they do tend to let you in. And yet there's also this incredible human-to-human informal communication just by looking in each other's eyes, where we negotiate very quickly, okay, are you going to let me in or are you not to? So the bullying driver I know is a hard case, but even before that, I think there's a much more common case of this negotiation that takes place, this little dance that goes on that's bi-directional, and we have a lot of work to do in order to solve that between an autonomous car and human-driven cars.
Great.
One more or no?
Sure.
Last one. How will Toyota's legendary approach to car manufacturing, did you write this question?
No.
Okay. The Kaizen way, aid in your adaptation to an autonomous fleet of Toyota vehicles, and when?
So I think maybe I answered it a little bit before, because it may be that big data is even more important than good software. So there's this wonderful phrase that software is eating the world, right?
Mm-hmm.
Well, it may be that data is eating software, and that it's really the data that's going to matter the most. And what Toyota, through continuous improvement, through Kaizen, has done has been able to grow the volume of cars that are made each year, around 10 million right now, to the extent that I think there's going to be this tremendous advantage in the amount of data that we get from those cars.
Well, thank you.
Thank you very much.
Appreciate it.
Thank you.
Will you take